My name is Neil Thompson, and this video will describe the 5 solar systems at my home at 126 Forest Park Boulevard, Janesville, Wisconsin. The 2001 solar domestic hot water system consists of 3 panels, and the system is powered by a DC powered pump with a small solar panel. And this system is supposed to provide a family of 4 with 75% of their hot water. I believe actually you get 100% in summer and 50% in winter. The food grade polypropylene glycol transfers in the basement through a heat exchanger into the domestic water system, which essentially preheats an 80-gallon tank that then serves the regular water heater. These 6 solar heating panels again are served and pumped by a PV powered pump from a small solar electric panel, and this drives the system from the panels underground over to the house. The beauty of the system is that when the sun shines, the system works. The insulated piping enters the basement from the crawl space and snakes its way through the basement utility area. For summer heat control, the fluid flows back to the panels via a bare copper pipe buried in the ground. The solar heating loop runs through a radiator just before the furnace. When the fluid reaches 106 degrees, the furnace fan turns on and the air is warmed 10 to 15 degrees. On a sunny summer day, this dump heating system can actually raise the temperature of this highly insulated house by 2 or 3 degrees. All 3 PV electric systems are grid-tied high-voltage systems. The interesting story is how the 2003 panels produced about 145 watts per panel, while the 210 PV panels of about the same size yielded 215 watts per panel. In 2018, the PV panels were rated at 315 watts per panel for almost the same size. There are outside solar electric disconnects for the utility companies and public safety personnel. The 2003 1.2 kW system has a Sunny Boy inverter with large external disconnect switches. The 210 2.15 kW system has a Fronius inverter with a very compact disconnect breakers inside the cabinet. The 2018 3.15 kW system has a Pika Energy islanding inverter connected to 4 emergency circuits that are powered when the utility power shuts off. This inverter is also connected to the HarborFlex battery unit made up of 4 52-pound lithium-ion batteries. These 3 PV systems take about 3+ hours to top off the batteries. In the evening and nighttime, the batteries power the entire house down to 30% of the battery charge.